things I've done with Python and Isatis.neo. And this isn't just going to be 15 minutes of me showing Julia set fractals, but that is something that you can do with Python and Isatis.neo because Python is a general purpose programming language. You can do a lot with it. But instead, what I've tried to do is choose examples that might be useful to you as a user of Isatis.neo. All of the examples presented in this talk came from user requests. So I've got automated estimation from parameters in a CSV file, printing statistics from different data tables to a CSV, and then a bit of talk on graphics and saving plots either for EDA or simulation validation purposes, and then calculating rotations from a wireframe that could potentially go past the vertical. The basic way Python works in Isatis.neo is you've got two places you can use it. One is the Python calculator inside the software itself, and that gives you access to a data table of the Isatis.neo project database, and that would allow you to do, for instance, very detailed simulation post-processing, or perhaps just simple data, transformations of variables. And you can also put blocks of Python code into a batch file. So the first example is estimating parameters from a CSV file. So if you've done any batch programming in Isatis.neo, you'd know that you can define arrays. You have array name equals variables, and then a list of the different variables that you want to, in this case, estimate. And then I've got an array for methods to say what sort of estimation technique I want to use, and then I've got some search parameters. And if you wanted to edit, for instance, the fourth of these estimate runs, you would have to count 1, 2, 3, 4 and change that one. 1, 2, 3, 4, change that one. That would be a little bit difficult to do because when you just have these values written as comma separated values in a text file, it's not easy to see how they line up. So it'd be much more convenient if you had all of this information in a CSV file. You can load in Excel and edit, read it very easily, one row per estimate set of parameters, and then you can very easily know where you're supposed to edit, make changes. So how would you do this in, make a batch file, read the parameters from a CSV and loop over them? So I'm basically going to start off with these early examples. I'm basically going to show the entire thing, all the nuts and bolts. As I get into more difficult, complicated examples, I'll just show conceptually what's going on. But for this one, you can pretty much show the entirety in one screenshot. So it starts at the top. This is a batch file. It's XML based. This is what batch files look like. And at the top of this batch file, I've got 2 lines of Python code. I import pandas, which is a standard pandas package. Makes reading CSV files very easy into what's called a data frame. So then a second line to load the CSV. Data frames are a specific type of object. You have fields corresponding to the field names in the CSV file. If you've used R, you'd be very familiar with data frames. So the CSV file is loaded, and then there's a for loop over over each row of that data frame. And then in this particular case, I've got a possibility to do either inverse distance or kriging. So if the method of I is the looping variable, so if the method is inverse distance, then I'm going to run quick interpolation down at the bottom. Else if condition is kriging, then I'm going to run kriging. And then the remaining part of how to set up these estimates is that you go through the parameters of the recorded task in the batch file and replace whatever you had in the software when you recorded it with a reference to the relevant parameter in the CSV file, which turned into a variable in the data frame. And that's pretty much it. That's one slide to describe how to use a CSV file to organize your estimation runs and sort of automate estimates over differing variables, search parameters, input files, domains, etc. Second example is printing statistics to a CSV file. So the problem here, this is something that we had in the old Isatis, and it's something that we have in Isatis.neo, is that if you have statistics on different data tables, or maybe you've got different selections on the one data table, the statistics tool only allows you to print stats from one at a time. So in this example here, I've got layer 1 and layer 1 underscore Q hold different variables on the same domain. And if I go to the statistics task and print them one at a time, I have this extraneous stuff in the middle that I don't really care about. So what I really want is just one table that I can very quickly copy paste into Excel or into a Word document. So the solution here is basically 3 steps. So in a batch file, there'll be a Python block of code will initialize a new CSV file. It's going to write the header line, the file variable count min max mean standard deviation CV, just the first line of it. Then in the batch file, there'll be a loop over the different variables that I want to print the statistics for, and it will load them into a calculator task, and the calculator task will be set to the whole file mode. And then in the calculator task, the statistics are calculated and appended to the end of the output CSV file. So how does this look? Once again, I'll show pretty much all the details here. So initializing a new CSV file. This is a batch file screenshot. I'm assuming that I've got a parameters CSV file to say which variables or domains I want to calculate the statistics for, very much like the first example in this talk. I'll loop over them, having read them into a pandas data frame. Then an output file for stats.csv. So first 2 lines of this Python block, same as previous, I'm importing pandas and reading the parameters file into a data frame. And then if you haven't seen Python before, this will look a little bit mysterious. I'm also mixing and matching pure Python with the Isatis.neo batch references to variables defined in the batch file. But the key point here is that I'm opening a new file and writing this line of text to it. It's telling me what my file variable count min max mean standard deviation CV. Little \n here is a new line character so that when I then append to this file later on, it will go onto a new line. So that's just initializing the file. Second step, in the batch file, loop over the variables, load them into calculator task using whole file mode. Okay, so the batch file, setting up a for loop, looping over all of the rows in my data frame or the CSV file that's controlling this calculator task, and then I go through the details of the calculator. I have to set the file appropriately. In general, you might have to change the table or the path. You might have to change the selection, and most importantly, the input variable. Now, in the calculator task, if you were to look at it in the GUI, in the interface itself, there's variables, behavior, whole file. Whole file mode gives you access to the entire data table or entire data table restricted to a selection at once. The input variables will be NumPy arrays, and then you can very easily calculate statistics from them using standard NumPy functions. This jumping back to a batch file, this is what the code looks like. This code here, this Python would be sort of, if I had not truncated the screenshot, it would be in the main section of Python code in the calculator task. The one little trap, if you're going to go away and try this yourself, is that a lot of the NumPy stats functions fail when you have missing data. And you'll find that if you use numpy.mean, you'll just get nan for not a number output. So you have to use a special nan functions to say ignore the missing values. So it's just one little trick. So it calculates all the relevant statistics that I want. it opens the output file in append mode. And again, this will look mysterious if you've never done Python before. This is just controlling how many decimal places I want to print to, but it prints the results to a new line of the CSV file that I want. And at the end of it all, I have in one convenient file all of my different variables, regardless of which data tables they came from. Very easy to then copy paste into a report. The next section is going to be on graphics. So this will be matplotlib, which is the standard library for plotting graphs in Python. This is just a screenshot of the matplotlib.org website. It says visualization with Python. It gives some examples. And then it says matplotlib makes easy things easy and hard things possible. And look, if you've never done matplotlib before, you're going to find the easy things pretty hard at first. You'll need to spend some time. The examples in the tutorial section of the website that they offer. But once you do get something going, it'll be easier this next time. You can always reuse your code if you're trying to do the same plots time after time. That's usually how things go. You get one thing working, and eventually you can reuse it, you can tweak it later on. How would you use this in the Isatis.neo context? Well, once again, you'll be in the calculator, which gives you access to the database, and you'll use whole file mode so that you get all of the data in a NumPy array. And then you import matplotlib.pyplot, and then you, here I've got some example code, fig, x equals plot.subplots. How do I know to write that? Well, because I found it in one of the examples on the website and I copy pasted it. X.plot v1, v2, and a little dot in quotes. This is the code to make a scatter plot. I change the x-axis title to y-axis title. I save it to a PNG, and what do we get? We get a very no-frills scatter plot, and that could be useful for you. At the moment in the software, at the time of recording, we don't have a save in batch mode for graphics, so this would also fill in a little gap in the software that should come in 2021. And you can extend these ideas a lot further because, as the Matplotlib website said, it makes hard things possible. Here I've got 5 variables. This was done on request by some people who turned up to a scripting day. They wanted histograms of different variables on the main diagonal, and on the off diagonal, they wanted scatter plots between different pairs of variables. This is just one calculated task, a lot more histogram, sort of a lot more matplotlib work. So I'm not going to show you all the gory details of the Python code here. I'm just showing you you are able to do this. The next graphics graphics example came from a sort of an internal request at GeoVariances, but it was a request motivated by some users in South America. They wanted some better simulation validation. And this will become a feature in the software sometime next year, probably. For now, we don't have it. What they wanted was a comparison of the cumulative distribution function for all realizations of a macro variable, so the simulations that they generated, with the CDF of the input data. Now, I say that and that's a very natural thing to want, but it does introduce a new challenge for the Python scripter in Isatis.neo, because a calculator only gives you one data table. And in the simulation validation context, we have input data on one data frame, the simulations on your output grid, which is a different data frame. So we need a way to somehow use data from 2 different data frames before plotting them to a final PNG image. And a solution here is to use global variables. Now, usually programmers will frown at you if you use global variables. They'll say that's bad practice, it indicates poor design. You should rewrite your code to avoid them. But they are very convenient in the Isatis.neo context when you're trying to transfer data from one calculator to a task to another, or from a calculated task to a Python block of code in the batch file. So I've started to use these more and more and more when I'm doing these multi-data table calculations. How does this work? There's a couple of different ways of doing it, but the way I'll show here is that in a block of Python code in the batch file, I declare a couple of variables as global and initialize their values. All CDFs is going to contain all of my CDF values, and then I've got a bin edges NumPy array, just calculating the histogram bins that will that I'll use for the call to the histogram calculation. Then in calculated tasks, calculate the histogram and then a cumulative sum. Divide it by the number of samples and you get a cumulative frequency, so for the CDF. So 2 tasks, one for the simulation, one for the input data. For the simulations, repeat code for each macro index. We'll do this calculation for each realization. And the way I've constructed these is that I'll just append to my list of CDFs for each macro index that it works its way through. Then the final, back in the batch file after the calculated task, there'll be a Python block of code to plot the lines of the different CDFs. And this is the result. There's just a bit of a toy example. There's only 8 simulations here, but the principle does work when you have many more. There's just a proof of concept. And I also have, with quite a lot more work on the calculation front, simulation validations as well of the variograms. And this is an improvement on the old Isatis variogram on grid tool, which gave you outputs that looked a lot like these. But in the old Isatis variogram on grid, if you had a rotated variogram model, you didn't know what grid increments you should use to match the rotation of your model. And the script that I have will approximate them for you. So you just have to sort of give your rotation, say what lags you want, and it'll approximate the grid increments and generate these plots accordingly. Last example, rotations from a wireframe. There's a bit of a gap in the software at the moment. The local anisotropies tool doesn't work when the input wireframe goes past vertical. We had a couple of users ask if it was possible in Isatis.neo to calculate the dip direction of each triangle in a wireframe, and this is possible. It was not possible in the old software. You didn't have access to the details of the wireframe. But in Isatis.neo, whenever you create or import a wireframe, you've got 2 useful data tables. You've got mesh vertices. These store the coordinates and a sample number of each vertex in the wireframe. And you have mesh surface facets. These are the triangles. The coordinates here are going to be the centroid of the triangle. And it also has these 3 index variables. These are the indices of the vertices that make up each triangle. So we've got 2 data tables here. So there's going to be another 2 data table calculation. Going to use a global variable for it. On the vertices table in the calculator, store the vertex coordinates into a global variable. And then on the facets data table, we have the index of the vertices, so we can look up the coordinates from our global variable using those indices. And then once you have the coordinates for the 3 corners of the triangle, you can do some vector geometry, some trigonometry, work out the angles. Maybe you could then do a nearest neighbor interpolation from the facets, so the triangle centroids to a grid, and then once you've got some rotations on a grid, you can construct a dedicated rotation variable, use that for local geostats. And this is an example where I've just made a little toy surface. It goes past the vertical here. I've colored the triangles according to the dip. You can see the dip goes to 90 degrees when it's vertical. It's all in order. And you know, I could then go further with that and construct rotations for local geostats. So the conclusions. Good use of Python and batch programming in Isatis.neo allows more convenient automation of tasks and outputs for reporting. Can sometimes fill gaps in the software, And when you have access to the full data tables, as you do in Isatis.neo's calculator, you can do a lot more powerful custom calculations than was possible in the old Isatis. So breaking new ground in what you can do inside the software with the batch programming with Python in Isatis.neo. And I'd say if you are an Isatis.neo user, I'm happy to share the examples that I've got or that I presented in this talk. If you want detailed Python-based drill hole spacing analysis from simulation post-processing, that would be a consulting project and we'd charge for it. But if you just want to print stats to CSV file, you want to do some simulation validation according to the ways that I've shown here, things that will become features in the somewhat near future, I'm very happy to share these with you and make you more productive in your use of Isatis.neo. Thank you.